Let's go ahead and take a look at this example. We've got the limit as x goes to 1 of x squared minus 1 in our numerator, and we have x cubed minus 1 in our denominator. And you'll notice that if we try direct substitution for this example, we can go ahead and plug in a 1 each time we see the x. And we're going to end up with 1 squared minus 1 on top, which will give us 1 minus 1, or 0. And in our denominator, we'll also end up with 1 minus 1 after we substitute those in, which also comes out to be a 0. And so you'll notice that we have 0 on top, 0 on the bottom. That's one of our indeterminate forms. So we're going to have to go ahead and try a different technique to evaluate this limit. You'll notice that both of these items can be factored in our numerator and denominator. So let's go ahead and factor our numerator. We have the x squared minus 1, which is a difference of perfect squares. And we can factor this into x minus 1 and x plus 1. And in our denominator, we had x cubed minus 1. And it might have been a while maybe since you took a look at factoring the difference of perfect cubes. So let's go ahead and take a moment to kind of give us a refresh on what that looks like. So towards the bottom of this slide, you're going to see the factorization for the difference of perfect cubes. Right, it's in that form, a minus b for our first set of parentheses. And in our second set of parentheses, that first term is going to be squared. The last term is going to be squared. And then the middle term is going to be each of those items multiplied together. So for us, it's going to be that 1 and the x. If you're looking at the signs, right, the sign inside of that binomial factor should be the same as your original item that you're trying to factor. In this case, it'll be a subtraction sign for us. And then in the trinomial portion, that first sign in front of that middle term is always going to be the opposite of whatever you started with. So ours was a difference of perfect cubes. That means for us it'll be a plus. And then your last sign there is always going to be positive. Let's return to our problem here and we can factor our denominator, right? We have x cubed minus 1. So our first factor is going to be x minus 1, right? We're taking the cubed root of each of those two terms. And then in our trinomial piece, right, the first term is going to be whatever this term was squared. So the x squared for the first term. Our last term is going to be that 1, also squared, which will just give us a 1. And then the middle term will be those two things multiplied together, right? The x and the 1. So we're going to have a 1x. I'm just going to write it as x in the middle. Right? Keep in mind when we're looking at the signs, right? This first one's going to be the opposite of whatever we started with. So in our case, it'll be positive. And our last sign is always going to be positive. Right? So there's our factorization. And one of the things that I want to make sure I mention in this is don't lose your limit notation as you're working through this problem, right? This would be a good example of something that a student would do. And they would neglect to write the limit piece and that notation in front of this rational function here. So let's go ahead and put it back in, because this is not a factoring problem, right? We're actually trying to find the limit here. So we want x as it goes towards 1. Right, and now you're going to notice that you have something in the numerator and denominator that you can go ahead and cancel. We can cancel these x minus 1s. Again, let's go ahead and rewrite this. Don't lose your limit notation. This will be x going towards 1. We have x plus 1 on top, and x squared plus x plus 1 on the bottom. Right, and now we can go ahead and try direct substitution. At this stage, you don't have to write the limit anymore as soon as you start to substitute in. So we're going to put the 1 in for the x. We'll get 1 plus 1 on top. And we'll have 1 squared plus 1 plus 1 in our denominator. And if we simplify this, we'll have 2 on top, 3 in our denominator. So the limit as x goes to 1 of x squared minus 1 on top and x cubed minus 1 on the bottom is going to be equal to 2/3.